Saxon Algebra 1, Lesson 41. Our topic today is adding like terms, but I'm not interested in talking about our topic just yet. I want to talk about the number of our lesson. There is not a black and white boundary between where we finish our review of last year's topics and we begin new material this year. It's kind of like the boundary between two countries, right? You look at it on a map and you think, oh, there's going to be like a black line on the ground. It's going to be really clear when we pass over from one into the other. But in real life, it's like when you actually do go to the border between two countries, especially if you go not to like a border crossing, you know, like a formal peace arch type checkpoint. But if you're just like wandering around in some field and you realize, oh, I think we've crossed over. I think we're in the other country now. That's how math is. We don't see for sure when we cross over into new material. We just kind of wander around and all of a sudden realize, wait, this is different than what we were doing last year. And that happens right around lesson 40. I consider 40 to be where the line is drawn. So we are officially being my opinion, and I mean, I don't know what could be more official than that, but we are officially into what I consider to be the new material. 1 through 40 is what I consider review. 40 through 80, I consider the meat of this course, and then 81 through 120, the last 40, is either really important stuff that we're going to go into more detail in Algebra 2, or important but kind of like dead-end topics that we're not going to build on, but John wants to toss them in and make sure that you have some idea what the heck he's talking about if you see those topics again. So we are now into the main body of Algebra 1. We have clearly stepped up and found ourselves in Canada or whatever country you'd like to be in. So here we go. Now I can talk about adding like terms. We know how to add like terms. We're just going to make them a little bit crazier, and I'll show you what I mean by that. And this is how you know you've crossed over into the new country. Look at what we're doing for adding like terms now. That's one term. It's kind of a monster, isn't it? Now the next one John writes as floaty, but you know how I feel about floaty. That's what we're supposed to add like terms on. This looks a little different than what we've seen in the past, doesn't it? I'm double checking just to make sure it's right. Yes. Yes, okay, this all looks good. So what we have to do is try to make something nice out of this chaos. Now, I've told you before that negative exponents are neither right nor wrong, right? They're neither good nor bad. It's just a question of sorting them out in whichever way makes sense given the problem. In this problem, because we are adding and subtracting these terms, we know the denominators are going to have to match. Shoot. They don't look very close to matching, do they here? I'm just going to give this one a 1. I didn't do anything to fix these denominators, or I didn't even bother to put the terms in alphabetical order. I just copied them straight out of the book, other than, and I told you this term was floating. I pushed it up because I don't believe in floaters, and then I gave it a 1 for a denominator. That's the only thing I changed. So the first thing we'd like to do, even though it's not right or wrong, is let's resolve all the negative exponents, make them flip and go away, so that we can see maybe John has been kind and maybe things will match up a little bit better if we can just take care of all the negative exponents. So that's going to be my step 1. We're going to fix. Now that implies that they're broken, and I just got done saying that negative exponents are neither right nor wrong. So take that with a grain of salt. Fix all negative exponents. I could have said something like make all negative exponents positive, Or I could have said change all negative exponents, but honestly, I was just trying to write the shortest thing I could, and fix is pretty short. So that's why I did that. Okay, so let's look at the first term. There's our negative exponent. So we're gonna flip him up. Remember, the rule is if you have a negative in your numerator, then the trapeze flips him down. Everything stays the same, right? It's still x to the n. We just burn off the minus sign. Or if you start with the minus sign in the bottom, then he flips up to the top. So that's two variations on the negative exponent rule, depending on whether your original trapeze, your original negative sign, is in the numerator or the denominator. We can do it both ways, right? Okay, so that's what we've got here. We've got this in the bottom, so we're gonna pop that up. Now, we also notice that we've got a quotient rule thing going on. So we're also going to, in the same, well, we'll just make it step 2, but we're doing these at the same time. Use rules for exponents. As needed, I won't write that, you know. Okay, so if we can do rules for exponents, we do. The one that we need here, because we've got an x to the 1 up there, right? We need the quotient rule because we are dividing. And that looks like, oh, if you've got fractions with matching bases and exponents, you subtract the top exponent minus the bottom exponent. All right, so that means this will become x to the minus 2, right? Here, let's fix this much of it. We'll have b x, and then we'll have y squared. There's the negative exponent. And then we'll have x cubed down there. First, we'll just fix the negative exponents because I'm getting too far ahead of myself. Okay, then we're going to send this one down. So this will become 3by squared. And then on the bottom, we'll have x squared, right? And then this, the b is going to go up. 4, and then remember, because it's just to the 1 power, we know that that 1 is only there because we need a place, we need something to chill with that negative sign, right? You just can't have a negative sign floating there. So we put the 1 in when it flips up like this, then we'll have b to the 1st power, and then we don't have to write the 1. So it'll 4by squared over x squared. Okay, so that was step 1. Now we'll do step 2. Now we'll fix any product, quotient, or power rule that we need to. And we can see, look, this and this, these look perfect, don't they? Look, by squared over x squared, by squared over x squared. Praise the Lord. Now all we have to do is use the rules for exponent on these two guys. And we'll be good because we already fixed this and we already fixed that. All right, so now we're doing this one. This will be x to the 1, right? Because there's an invisible 1 up there, minus 3. That equals x to the minus 2. And then we're going to send that x to the minus 2 equals 1 over x squared. So we're going to flip him down. So when this simplifies, it's going to be b, the x is going to go away because it's going down to the basement. By squared over x squared is our new fixed new term. And look, minus 3by squared over x squared plus 4by squared over x squared. Look, everything matches. So now we can add or subtract as indicated. If it is helpful, and I think it is, put a 1 there so you can compare. Now we can ignore these bundles of variables and we can just say 1 minus 3 plus 4 equals 2, and then we'll write all the letters back. Make sense? That's our final answer. We did not solve for x, b, or y. We simplified in this, right? There's no equal sign anywhere in sight. It's an expression with 3 terms. We simplified it first by fixing the negative exponents. Again, not fixing, changing. And then we use the rules for exponents as needed. If you feel super sharp and on your game and you want to correct both of these things at the same time, you may do that. But when I say I want your homework to look just like mine, I'm not kidding. You don't have to write the steps, but I want you to circle and show me step by step what you did. I want you to show me a little side calculation here, how you figured out that those 2 x's net down to an x squared in the bottom. I want you to show me, because here's the thing. If you truly understand how to do this, it'll be a piece of cake for you to write it down. Students who really have a good grasp of what's going on have no problem with writing things down. So whenever a student complains to me, oh, I don't want to write that down, that is too much, I know they're probably a little bit confused, because it's more confusing to write things down when you don't completely understand them. It's easier to just like have some sort of intuitive zap in your brain and go, yeah, I think that's right, it feels right. If you really understand it, writing it down's not a big deal. So I am challenging you to write out all the problems in today's homework lesson. Take your time and really like pretend you're me, right? Show every little step. I mean, you don't have to really pretend you're me, because that I realize is a little scary, but you know what I'm saying, right? Take your time and really attend to the details of the problem. 41.2, ready? It's ugly. Again, I'm copying this just the way John has it. I'm not doing any fixing along the way. And I don't want you to yet either, because it's too easy to make mistakes. In a while, a week or so, I'll show you some shortcutty ways that you can make this go a little faster, but for now I want you to do it the slow way. Okay, we're gonna do the same thing again. We're going to fix the negative x. I said it again. We're gonna change all the negatives into positives and see what we get. So this b is gonna come up. So it will be b to the third, because I'm fixing this and this in the first term. B to the third, b to the 1. Oh, I can see what's gonna happen there. And then downstairs, we're gonna have a to the third, right? And then this, there's nothing to fix, is there? So that's changing negative exponents into positives. Now I'm gonna use my product rule to combine those. So that'll be b to the 4th over a cubed plus, oh look, John, you're so nice. And the last thing we'll do is put a 1 coefficient there, because then we can say 1 plus 2 equals 3, and then we'll write the whole thing out. 3b to the 4th over a cubed, yay. You can say a cubed, or you can say a to the 3rd, okay? You can say a squared, or a to the 2nd power, okay? What we don't say is a to the squared. Take the out. The 2 and the 3 are the only numbers that have words, right? Square and cube. We don't say like b to the quad or anything like that. Once you get past 3, you just say b to the 4th, b to the 5th, b to the 6th. All right, so it's just a squared, a cubed. Those 2 words you can say simply. Okay, guess what? We're done, and that's right. I don't think I smiley faced my first one, did I? 2by squared x squared. It's right. Heck yes. Okay, one more of these, and then we have a quick side topic. Example 41.3. It's a second topic. You know how John is. 7. Okay, that's the way John presents this to us. I have not changed anything, and here's the thing. I don't want you to start changing these problems yet either. I want you to copy them down exactly as they're written, and then I want you to find what needs to be changed. In a few lessons, and I'll tell you when, I'm going to change the rules, and I'm going to let you start doing some of the steps in your head as you copy the problem from the book onto your paper. But not yet, because it's too easy to make mistakes and to get tangled up in these spider webby problems and get confused about what you're doing. So for now, copy it just the way it looks and go step by step. First step is to change any negative exponents to positive. So I want you to circle them. There's 3 of them. Okay, now we're just going to change them. We're not going to use any rules for exponents yet. Okay, and I'm going to keep them alphabetical. So I'm going to keep the b squared up. The a is going to be going down. The c is coming up. It's a 1. That 1 is just there to give the trapeze something to hang on to. But I don't need a positive 1 up there. That's ridiculous. Now I'll have a to the 3rd. Okay, minus, let's bring the c up. 5b squared c over a cubed. Hey, look, they match. It's so fun when they match, isn't it? It's very rewarding. Plus 3b squared over a cubed c. That one has nothing to fix. According to my copying of this, this is how it sits, and now I see, shoot, this 3rd one doesn't match. So here's what I do. Just to be sure, I'm going to go back and make sure I copied this problem right and I didn't accidentally leave anything out. Because, excuse me, I'm so sorry. Because I'd really like to see that C jump up to the numerator, wouldn't you? So I go back and I look at the problem and I say, dang, no, it doesn't combine. This one is not a match. And even though we have the same letter and it's just a question of whether it's upstairs or downstairs, Nova, it doesn't work, so we can't do it. So our final answer is that we can combine these 2, but not him. So 7 minus 5 is 2b squared c over a to the 3rd plus this other thing, untouched. And that is as good as it's going to get. Isn't that sad? I mean, kind of, right? I don't know how much emotion you feel for problems that don't work out, but the struggle is real. Okay, let's do the other part. Again, these are familiar problems, and doing these problems was definitely a part of your review. These are 2-step problems. But we're now doing slightly more challenging. I mean, we've baby stepped it up a little bit. So these problems are now considered Algebra 1 type problems. These are 2-step equations. All right, example 41.4. If you've been doing Saxon for a while, you're going to be like, yeah, this is not hard. Okay, the question says, if x plus 3 equals 7. Excuse me. What is, okay, this is how these problems always look. If something with an equation, right, it has an equal sign, so we know it's an equation, it can be solved for x, right? If that, then what is this? Notice this is an expression. There's no equal sign. Unless we know a value for x that we can plug in here, there's nothing we can do, because x minus 8, we got nothing, right? However, if we can solve this one, which we can because it is an equation, then we can take that value and plug it in here. Okay, so that's what we do. X minus 3 equals 7, so this is kind of like Algebra 101, right? Well, you're in Algebra 1, so I guess that doesn't make sense. These cancel, and we get x equals 4. Then we take that 4 over to our equation, and we say that it is, I'm going to use buckets to show how I plugged it in. 4 minus 8 equals negative 4, and that's our answer. Okay? So we started with an equation that we could solve and get a value. We took that value and we plugged it into the expression. Then we were able to get a value for that expression, right? But remember, without this, nothing. That doesn't make any sense to us at all. Okay, so that's the step-by-step process. First, we solve the equation, and then second, we plug that value in. Okay, I think I've hammered this home well enough. There's one more of these problems. It's example 41.5, and it goes like this. If x minus 5 equals 7, what is... And John writes, what is the value of, you know me, I'm not going to write all that out. What is x plus 4? Again, very same pattern. Equation, expression. We can't do anything with that, but if we solve for this, then we'll have a value for x, and we can plug it in there. So this time, I'm not going to write anything. I'm just going to show you exactly how I want you to do the problem. Those cancel. X equals 12, and then we take it. I like to draw an arrow to show, oh look, I'm using this to connect with that, and I get 12, and I put that to show that's the part I'm plugging in, plus 4 equals 16. And guess what? Happy days, that's the right answer, and we're done. So these should be old familiar friends. We are going to, these weren't, the algebra was pretty straightforward in these, but we're going to bump up the algebra. We're going to do problems like this for quite some time because you can do any kind of algebra you want, right? As long as you can solve the first one and then plug it in the second one. It's good. Look, we're on week 12. This is the penultimate week of new lessons. Can you believe that? We're almost to Christmas. It's very exciting. Okay, thank you. Goodbye.